Okay, so now we want to finish up the video for 12.1, and we want to talk about graphs, and especially we want to talk about visually deceptive graphs. So this will allow us to finish our fourth, This will allow us to finish our fourth objective, identify deceptions in visual displays of data. Alright, so in my last video, we talked about two different types of graphs. We talked about the histogram, right, which is a bar chart. We talked about the frequency polygon, or the polygon graph, okay, as a way of showing data. So what are some ways that you can mess that up? Alright, so if you take a look, deceptions, in visual displays of data, if you look at this one, the graph goes up very, very sharply, and you're thinking that there's a large increase from year to year in the poverty rate. But if you look at the actual data, it's going up very, very slowly. 0.4%, 0.4%, 0.4%, 0.2%. Okay? So you've gone up barely 1% in a 4-year period, 5-year period. And so why does it look like this? Alright, well, it looks like this because they've broken the scale, alright, at the 0, and they've gone up by these 0.4 amounts each time from this broken scale. And so because they've broken the scale at the 0, it looks like they're going very, very fast up. Whereas here, they've broken the scale, but at least they are consistent in how far they're going up each time. And so now it looks very, very flat. Okay? So graphs can be used to distort the underlying data, and one of the biggest ones that I see is that the graph on the left stretches the scale on the vertical axis to create an impression of a rapidly increasing poverty rate. The graph on the right compresses the scale on the vertical axis to create an impression of a slowly increasing poverty rate. Now, I would say that this graph on the right better depicts the poverty rate over here in the actual data. But they're both suffering from the broken scale issue, okay? And so what would make both of these graphs better is if they were to start at 0 and then go up by the same amount. This follows the same idea of the class widths remaining the same. Go up by the same amount each time, and then we could judge for ourselves how fast it is actually going up or down. So broken scales is a terrible method, and you should always be leery of a graph with a broken scale. Alright? Things to watch for. Besides the broken scale, what are some of the things we should watch for? Well, is there a title that explains what is being displayed? Alright, that's very important. Are numbers lined up with tick marks on the vertical axis that clearly indicate the scale? Has the scale been varied to create a more or less dramatic impression than shown by the actual data? This is what happens with the broken scale, okay? But if you vary between, you notice, this one is going up by 0.4 each time, this one is going up by 2% each time. So one exaggerates it with the scale, one compresses it with the scale. At least they are consistent in between each of these scales, and so that's really important, okay? You certainly don't want it to vary that. Do too many design and cosmetic effects draw attention from or distort the data? Has the wrong impression been created about how the data are changing because equally spaced time intervals are not used on the horizontal axis? Okay? Now, it turns out that I have the perfect graph that lines up with these, okay? About scale, cosmetic defects, and maybe not necessarily a wrong impression, but a confusing impression, okay? And so this is a graph that Paul Krugman created and put up on his website, okay? And you'll notice that there is a complete lack of scale over on this side, okay? Now, while the bars are the same size, right, from January 1st to March 04, January 9th to March 12, it's the same time period, okay? And there is a title, Job Losses in Two Administrations. If you'll look at this, the lack of scale over here doesn't tell us whether this is actually 1,500 jobs, 150,000 jobs, 1.5 million jobs, which is what it actually is. I was not the only person to point this out. The Huffington Post actually published an article about this particular chart that Krugman used, and said Krugman doesn't label his axes, but a call to the Bureau of Labor and Statistics confirmed that his chart is meant to be read in the thousands, and we checked his figures against the Bureau of Labor and Statistics website. So we had to do some independent confirmation about this. The other thing that's problematic is the cosmetic defects. Blue is typically for the Democratic Party, and he's associating it with Bush, which is the Republican Party. Red is typically reserved for Republicans, and he's associating it with Barack Obama's administration. So the colors lead to some confusion, a cosmetic effect. So there could be a wrong interpretation of this graph, so with the scale and stuff. Now I want to point out that Paul Krugman is a Princeton professor of economics. He has a PhD and a Nobel Prize. I do not want to say that he created this graph to be misleading on purpose. I just want to say that maybe he was under a time constraint or something. But if a Nobel Prize winning economist, somebody with a PhD, somebody who works at Princeton can create a bad graphic like this, that has the chance to be misinterpreted, then what other data and stuff are we looking at that is also misleading? Alright? So I just wanted to throw that out there because I think that's a great example that all data has the potential to be misinterpreted. So some more things to watch for. Number 5, are the bar sizes scaled proportionately in terms of the data they represent? Is there a source that indicates where the data displays come from? Does the data come from an entire population or a sample? Was a random sample used, and if so, are there possible differences between what is displayed in the graph and what is occurring in the entire population? Who is presenting the visual display, and do they have a special case to make for or against the trend shown? So this is some of the interpretation, are those things available? Now, I do not believe the Krugman graph actually references the Bureau of Labor and Statistics, so this is another issue with this. But we were fairly easily able to fact check it, but we shouldn't have to. Is it a sample? What's the margin of error? What are we doing? What is the source of the information so we can look at it for ourselves? Very, very important. Okay? So be careful of misleading data. This brings us to our last slide about cosmetic effects that happen. Examples of misleading visual data. Cosmetic effects of homes with equal heights but different frontal additions and shadow lengths make it impossible to tell if they are proportionately depict the given areas. Time intervals on the horizontal axis are not uniform inside, making it appear as that the dwelling is swelling has been linear from 1970 through 2004. The data indicate that this is actually not the case. There was a greater increase in area from 70 to 1990, average of 29 square feet per year, than from 1990 to 2004, where it's only 19.2 square feet per year. But this is the misleading graph right here. Look, they're changing two dimensions. They're changing the frontal area, but they're also changing the height over here. Okay? And so when you change stuff in two dimensions like this, you create a disproportionate effect. And then, I'm sorry it didn't come out better on the slide, but again, this is 1970, this is 1990, and this is 2004. And so this represents 20 years. Sorry, I can do math. This represents 20 years, but this only represents 14 years. So the distances aren't the same here. Okay, so this is very misleading, and this was taken right out of a magazine, and I think they just wanted to jazz up the display of the data with the shadows and make it look artistic. But the problem with that is it becomes very misleading. Okay, and so you just have to be very, very careful about the information that you look at, and when you do that, that makes me happy.